there are chances wherein when you're evaluating a function, there exists an indeterminate form. Okay, so when the numerator and the denominator is 0, then the 0 over 0 form is undefined under the evaluating function. However, in the rule of limits, the indeterminate form of type 0 over 0 means that the limit also exists. Now, to discuss that, let us first have the factorization method as a way of eliminating the 0 over 0 form. Now, in the factoring technique, then the numerator, denominator must have a certain expression true to them so that they are factorable. Okay, let's have number 1. The x squared plus x divided by x is 0 over 0 when x is 0. It is very obvious in the numerator and denominator. Therefore, we need to have the factoring technique. And as observed, we can bring out x here and x so that the simplified expression will be x plus 1. So that x plus 1 will be used as a simplified form of this. And let x be equal to 0 now. So 0 plus 1 is 1. The second example, we can factor it out and bring out x squared so that the simplified expression will now be x plus 1 plus x squared. Now substitute 0 to the expression. So we have 0 plus 1 plus 0 squared, or simply 1. Third, we factor out. So we have x times x plus 1 in the numerator and x times x plus 3 in the denominator, so that our simplified form is x plus 1 divided by x plus 3. That is the time for you to substitute x that is equal to 0. So our limit is 1/3. And remember that we can only do factoring and other methods when we were able to observe 0 over 0 or the indeterminate. But if 0 over 0 or indeterminate is not found or not determined in direct substitution, so direct substitution can be utilized immediately. On the next example, we can just bring out x here so that e raised to x plus 2 is left as a simplified expression. Now substitute, let x be equal to 0. So e raised to 0 is 1. So 1 plus 2 is 3. The fifth example would like to remind us that we need to recall a raised to m times a raised to n is equal to a raised to m plus n as the rule of exponent. Also, a raised to m, the quantity raised to n, is equal to a raised to the product of m and n. Therefore, from 2 raised to 2x minus 2 raised to x plus 2 divided by 2 raised to x minus 4, the first thing we need to observe here, indeterminate siya pag direct substitution here. Pero kapag obserbahan natin, pwede tayong mag-factor out. We can bring out 2 raised to x and 2 raised to x, both terms in the numerator. Kasi ang 2 raised to 2x can be expanded here. And 2 raised to x plus 2 can be separated 2 raised to x times 2 raised to 2. Okay. Factoring it out, pwede natin ilabas na ang 2 raised to x. Kasi itong dalawang terms ay parehong may 2 raised to x. So ilabas natin so that we can now cancel out 2 raised to x minus 4. So ano ang natira? We have 2 raised to x. And that is the time for you to substitute x that is equal to 2. So 2 raised to 2 now is 4. So the limit is 4. On number 6, kitang-kita natin na pwede nating itanggalin ang logarithm of x. Because kapag sinubstitute mo yan agad, logarithm of 1 kasi is 0. So 0 numerator, 0 din ang denominator. So magiging 0 over 0 form, which should not be, right? So here, we can cancel out logarithm of x. So ang natira ay x times logarithm of 3. Let x be equal to 1. So we have 1 times logarithm of 3 is logarithm of 3. Remember that you can still end your answer in logarithmic form kasi these are now considered to be constants, no? And in limits, we are not approximating the limit. So kung logarithm of 2 yan, logarithm of 11, logarithm of 7, now these are not cannot be expressed as a whole number anymore, then just end your answer in logarithmic form. Now in number 7, we have the idea that when we get the product of square root of a times square root of b, then we can have square root of the product of a and b. So it means therefore that the square root of ab is expanded into square root of a times square root of b. At the same time, we also try to recall that square root of a over b can also be square root of a divided by square root of b. Okay? So, dito sa given natin, pwede natin gamitin yun. Square root of 5x minus x squared divided by square root of 5 minus x. Pwede kasing mag-expand si square root of 5x minus x squared. And we have square root of x times 5 minus x. Pwede rin lumabas ang square root of x as suggested by the given here. Therefore, ano ang natirang expression? We have square root of x. Okay, kasi ika-cancel na natin ito. So you see, in the factoring technique, we can just cancel it out. At ang pag-cancel sa square root of 5 minus x, hindi na magsi-zero ang numerator and denominator. And that is the time for you to substitute kasi ang equivalent ng given ay square root of x. Ngayon, let x be equal to 5. Therefore, our answer is square root of 5. That is the limit. Then, and here we can just cancel out cube root of x minus 1 so that 0 over 0 form will no longer exist. Now, you will substitute 1 to x. So 1 plus 6 is 7. Now we can also have the trigo functions wherein here the limit of x over x times cosine x as x approaches 0. So here it is obvious that we can immediately cancel out x here so that we cannot have 0 over 0 form. Therefore, from x over x cosine x will become 1 over cosine x. Now we let x be equal to 0, so that will be 1 divided by cosine 0. And remember that cosine 0 is equal to 1. Cosine 0 is equal to 1, so substitute. So 1 divided by 1 is 1. So the limit is 1. Now on the next example, the limit of sine squared x cosine x divided by sine x as x approaches pi. So here, take note of this square. We can actually expand that into sine x times sine x. Therefore, we can cancel out 1 sine x. So ano na iwan? We have sine x times cosine x. We now substitute pi, so sine x divided by multiplied to cosine x will become sine pi times cosine pi. Sine pi is 0 and cosine pi is negative 1. So 0 times negative 1 is 0. So in the factoring technique, the first thing you need to do is to observe if the given will become 0 over 0 or indeterminate. So if it is not 0 over 0 form, then direct substitution can be used. But if it is 0 over 0, you have to take a look if you can factor it out. So if it is not factorable, then we will now have the other way. And that is to be explained next. If the factoring technique is not applicable in removing the indeterminate form, then it means that you will now have to choose the other way, and we call it as the conjugation method. Okay, now the conjugation method is derived from the idea of the product and sum of the two terms. The product and the sum of two terms, when you're going to get the product, will give you the difference of two squares. And the idea of conjugation is used for us to remove radicals. Now, usually you will encounter radical numbers, and that radical numbers will remind you of using conjugation. But for what? Okay, our intention here is to remove the reason why we can have that zero. We need to remove that particular expression so that zero in the numerator or zero in the denominator will be removed. So in the conjugation process, when you observe an addition as the separating operation to the two terms, babaliktarin mo yan at gawin mo siyang subtraction. So if you have square root of x minus 3, so its conjugate is square root of x plus 3. So you just need to get the opposite operation, addition turn subtraction, and subtraction turn to addition. So what about if you are referring to cube root functions? So how are we going to get the conjugate of it? Recall that it is very simple for radical numbers to get the conjugate. So it's square root of x plus 10. Its conjugate is square root of x minus 10. But when we encounter cube root, fourth root, fifth root, seventh root like that, let's say 1 minus square root of or cube root of x, its conjugate will now be first from subtraction to addition. So we have cube root of x. So our assumption here is this is raised to 1 plus cube root of x. This is raised to 2. Therefore, the conjugate of 1 minus cube root of x is 1 plus cube root of x plus the square of cube root of x. But what about for fourth root? Let's say 2 minus fourth root of x, and that will become 2 plus fourth root of x. Assume that that is raised to 1. Fourth root of x raised to 2. And fourth root of x raised to 3. So the clue here is when the index of the radical number is 4 or 3 or any other integer, then the highest exponent or the degree of its conjugate is 1 less than the index of the radical number. So from 4 it becomes 3, or from 3 then you have 2 as the highest exponent. So let's say, for example, we can also have 5 minus fifth root of x, and that will become 5 plus fifth root of x. So let's say that is raised to 1. This one is raised to 2. So next, fifth root of x, this will be raised to 3 plus fifth root of x. So this is raised to 4. So you will end up in 4 as the highest exponent. So that is how we conjugate radicals with an even with 2 as the index and 3, 4, 5, 6, and all other positive integers as the index of the radical number. So let us now use the conjugation. So here, if we try to evaluate the limit of x minus 4 divided by square root of x minus 2 as x approaches 4, okay, let's first verify. If we let x be equal to 4, then if we have 4 minus 4 in the numerator, and the square root of 4 is 2, 2 minus 2 is 0. So meron tayong indeterminate form. That will now tell you that you have to make use of the conjugation. We cannot use factoring here because obviously we cannot factor it out. Now, in the conjugation process, we focus in the denominator. So this one is subtraction. Its conjugate, there must be addition. So you're going to multiply square root of x plus 2 and square root of x plus 2 to the numerator and the denominator. Okay, so when you are going to get the product in the denominator, you are now following the rule a plus b times a minus b is equal to the square of a minus the square root of b. So if you get the square of the first term, that is square root of x, then we can just cancel out square and square root and get the square of 2, and that is equal to 4. Therefore, we have to cancel out x minus 4 in the denominator, and in the numerator, our simplified number or expression is square root of x plus 2. So what are we going to use or going to do in square root of x plus 2? We're going now to substitute x that is equal to 4. Substituting x that is equal to 4 to the simplified expression will give us square root of 4 plus 2, and that is 2 plus 2. The answer is 4. So that is the limit of the function. Now in the second example, we are going to evaluate square root of x minus 3 as x minus 9 as x approaches 9. So here, square root of 9 is 3, so 3 minus 3 gives you 0 in the denominator. 9 minus 9 is also 0, so 0 over 0 form is indeterminate. Now, subtraction is used in the denominator, so the conjugate of square root of x minus 3 is square root of x plus 3. Now, multiply that numerator and in the denominator. So in the numerator, you're going to square root of x, so cancel square 3, and that is 9. Subtraction is retained. So you have x minus 9, cancel it out. So in square root of x plus 3 will be left as a denominator. We now have the simplified form 1 over square root of x plus 3. You are now ready for the substitution. We let x be equal to 9. So 1 divided by square root of 9 plus 3 is 1 over 3 plus 3, and that is 6. The answer is 1 over 6. Also, if you have limit of square root of 1 plus x minus 1 divided by x as x approaches 0, it is very obvious that in the denominator x really will become 0. And in the numerator, square root of 1 plus 0 minus 1 is 0. Therefore, if we're going to get the conjugate of square root of 1 plus x minus 1, and that is square root of 1 plus x plus 1, you just need to get the opposite. Okay, now do it in the numerator and denominator. Multiply. We can now cancel the first term, square root of 1 plus x, and get the square of 1. Okay, so that will now give us 1 minus 1 is 0. So x is left. X divided by x in the denominator is 1. So 1 over square root of 1 plus x plus 1 will be the final expression. Now you let x be equal to 0. So 1 plus 0 is 1. Square root of 1 is 1. So 1 divided by 1 plus 1 is equal to 1 half. So that is the limit of the function. Now on the fourth example, we are now being guided by the two special products, the difference of cubes. If you're going to get the difference of two cubes here, when we see a subtraction here, then we will follow that as the first factor. Getting the bases a and b, get them, and get the difference a minus b. Now, a just represents the first term and b is the second term. Square the first term, and that is a. Square the last term, which is b. Now get the sum, get the product of the first and the second term. Now, if the operation is subtraction, that is difference, then these two must be positive or addition. But when we are referring to the sum of two cubes, from addition, follow it out. But when you go to the second factor, alternating, this is positive, the other is negative, and this is positive. That is why you observe here positive, negative sign. Okay, now let's try it. In the limit of square root of x minus 1 divided by x minus 3 minus 1, or x raised to 3 minus 1, as x approaches 1, is obviously indeterminate. Now, the conjugate of square root of x minus 1 is square root of x plus 1. Now, multiply that to the numerator and denominator. Now, get the square of square root of x, square 1. So you have x minus 1. Now this x minus 1 can be derived from x cubed minus 1. Take note that x cubed minus 1 is also equal to x cubed minus 1, the cube of 1. Now the base is x, the other base is 1. It follows na kapag ginamit mo ang subtraction dun, then subtraction ng unang factor. Square the first term, which is x. Square the last term, which is 1. And get the product of the first and the second terms. 1 times x is x. And since that is subtraction, then the 2 or the 3 terms must be positive. So that gives us x minus 1 times x squared plus x plus 1. Therefore, we can now cancel out x minus 1 sa denominator. Canceling that will give us the simplified expression, and that is 1 over x squared plus x plus 1. This x squared plus x plus 1 is the other factor left after removing x minus 1. And the square root of x plus 1 is the conjugate. Okay, now we're ready for the substitution. The operation must be removed already, the limit notation. So we now have 1 over, let x be equal to 1 here. Our final answer will now give us 1 over 6 is our final answer. Because this is 1 plus 1 plus 1, that is 3. Square root of 1 is 1. 1 plus 1 is 2. So 3 times 2, 6. So we have 1 over 6. Now in number 5, we are going to evaluate the limit of the square root of x plus 2 minus 2 divided by x minus 2. So you just need to get the conjugate from minus, turn plus. Okay, square, cancel. So x plus 2, bring down the radicand, x plus 2, we'll just copy it. So x plus 2 minus 4 is x minus 2. We can now cancel the numerator and denominator x minus 1. So what is the difference? It is 1. So you have 1 over square root of x plus 2 as the final expression to be used. Now you let x be equal to 2. So you have 1 over square root of 2 plus 2 will give you 1 divided by square root of 4, which is 2, plus 2 is 4. So the final answer will now be fraction 1 over 4. Now, we will meet the cube root. Now, cube root, unlike square root, has another meaning. So the conjugate of 1 minus cube root of x plus 1. Okay, what did I tell you a while ago? This is the first, raised to 1. The second is raised to 2. Since that is cube root, you are now limited to 2 as the degree. Okay, so you now have to multiply the conjugate 1 plus cube root of x plus 1 plus cube root of, or the square of the cube root of x plus 1 to the numerator and denominator. And using now the FOIL method, your favorite FOIL method, then you're now getting to, you will now get the product of 1 times the entire quantity is the quantity itself. Now multiply the second term. This is the second term, cube root of x plus 1 to the entire quantity will give you, okay, we start from the first term. Cube root of x plus 1 times 1 is itself cube root of x plus 1. Now cube root of x plus 1 times cube root of x plus 1 is the square of cube root of x plus 1. If we're going to get the product of the cube root of x plus 1 to the square of the cube root of x plus 1, it will become the cube of the cube root of x plus 1. That is the reason why we can immediately remove cube root and the power of 3. Okay, now combine like terms, we can now cancel out the like terms here. Okay, so anong natira? Bring down 1. I'm going to bring down 1 and the x plus 1 or negative x plus 1. And that will give you negative x. Negative x divided by x is negative 1. Okay, now we're ready for the substitution. You let x be equal to 0 and palitan lahat ng x dito into 0 will give you 1. Cube root of 1 is 1. Cube root of 1 and raised to 2 is also 1. So 1 plus 1 plus 1 is 3. And since that is negative, our final answer is negative 1/3. Now, if you are referring to the cube root or fourth root, okay, in the fourth root, you are just counting in getting the conjugate, you are just doing get the unlike operation from subtraction to addition. This is raised to 1, raised to 2, up to raised to 3 only because just like what I've told you, just decrease 1 from the index. Okay, now multiply that to the entire expression, numerator and denominator. Okay, then we now have the product, which is multiplying 1 to the entire quantity. So the entire quantity here will give you the quantity itself. Now if you multiply fourth root of x plus 1 to the entire quantity, okay, multiplying this fourth root to the entire quantity here will give you fourth root of x plus 1, okay, plus the square of fourth root of x plus 1, cube of fourth root of x plus 1, and fourth root or fourth power of the fourth root of x plus 1. Cancel this out now. That's why you have x plus 1 here. And getting the final sign, okay, change the sign when you see subtraction right here. Change the sign of all the quantities inside. And combine like terms, we have fourth root of x plus 1. They are like terms, so that is 0. Square of the fourth root plus negative square of the fourth root of x plus 1 is 0. And so with the cube root or the cube of the fourth root of x plus 1, there it becomes 0. Now bring down the constant 1 and bring down the radicand, formerly the radicand previously, that is x plus 1. Combine like terms, so 1 minus x plus 1 is equal to 1 minus x minus 1, and that is equal to negative x here. So from negative x, you divide that to x, will give you negative 1. And since that is already simplified, and you cannot have 0 over 0 form anymore, you are now ready to substitute x that is equal to 0. Now substituting x that is equal to 0 will give you the denominator, which is 4, and the numerator is negative 1. So the final answer is negative 1 over 4. So you see the need of conjugation. The first thing you need to do is to check whether the given function is indeterminate at a given value of x. When it is indeterminate, take a look if you can make use of the conjugation. If not, then maybe the factorization is applicable. And all other rules, there are so many rules that we can study, but at this time we are limited to these two. Now, always take note that the limit is not solved by direct substitution at all times. So when it is not solved by direct substitution, then the factoring or the conjugation can be used. But there are also chances wherein these two are not applicable. And those will be studied as we go through our lessons.